Section 2.4 is about writing linear equations. We'll start by looking at the slope-intercept form of an equation. You see it down here, y equals mx plus b. If you remember, the m represents the slope and the y-intercept is represented by the letter b at the end. What that means is m being the steepness of the line, as we've learned about, and the b is the y-coordinate of the ordered pair where the line touches the y-axis. Now, with that information, you can take and write equations of lines if you're given a slope and an intercept. So here's an example of that. We want to write the slope-intercept form. It's going to have a slope of negative 3 over 2, and it's going to pass through this point. Now, the one thing that we're missing is we're missing the b, but we are given the m. So I'm going to write slope-intercept form here, y equals mx plus b, just to remind you what it looks like. And I'm going to write down that we know that the m is negative 3 over 2. We're given that information. But what we don't know is we don't know what the b is. We don't know the y-intercept. I can find that, though, by taking my ordered pair that I'm given, my x and y ordered pair. This is the x, this is the y, and plugging them into the equation along with the m. So for y, I'm going to put a 1. For m, I'm going to put negative 3 over 2. And for the x, I'm going to put negative 4. And then we can solve for the b using algebra. This is a negative 4 over 1, so I can cancel 2 and 4, leaving a negative 2. Negative 3 times negative 2 is 6. And now I can isolate the b by subtracting 6. So we end up with b equaling negative 5. So we now know that the y-intercept is negative 5. We were already given the slope of negative 3 halves, so I can write my equation now. Y equals m x plus b. In this case, it would be minus 5 because it's plus a negative 5. Another way of writing linear equations is using the point-slope form, like you see here. This is another form, and it uses slope again, so it uses the m. But this time, along with the x and the y, which should stay as variables, we're given an x sub 1 and a y sub 1. And those are representative of the coordinates of a point that lie on the line. So whatever numbers are in the coordinates, you put as the x sub 1 and the y sub 1. Let's take a look at that. We want to write an equation, and it's going to pass through these 2 points. So we need to find what the slope is using these 2 points. The way we do that is we use the slope formula that we learned a couple sections ago. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember, it doesn't matter what order you put the y's. I'm going to go 5 minus 4. But then once you pick the order, you have to stay consistent, which means my x's will have to be negative 4 minus negative 1. 5 minus 4 is 1. This is really a negative 4 plus 1, because minus and negative is the same as plus. So that's going to be a negative 3. So my slope, my m, is negative 1/3. Now, because we just learned about point-slope form, I'm going to write my equation in that form. And the way I'm going to do it is I'm going to put my m, or my slope, my negative 1/3, in for my m, and I'm going to put one of my points in for the x sub 1 and y sub 1. It doesn't matter what point you pick. I'll choose the negative 1 and 4, which means this is going to be 1 minus 4. And my m is negative 1/3 with an x minus negative 1. Now, there is some simplification that needs to happen here. I'm going to make this y minus 4 equals negative 1/3 x. I'm distributing now. This is going to be a plus 1 because minus and negative is a plus, but then I'm going to multiply that plus 1 by a negative 1/3. So this will be a minus 1/3. Now, because typically when we are asked to write an equation, we want it in slope-intercept form, I want to isolate the y, so I'm going to bring the 4 over. But if I'm going to add 4 to negative 1/3, it becomes a lot easier if I make that 4 into a fraction with a 3 on the bottom. So how can I write 4 as a fraction with 3 on the bottom? I can make it 12/3. So instead of adding 4, I'm going to add 12/3, and that way I can put those like terms together. So my final answer becomes negative 1/3 x. Negative 1/3 plus 12/3 is 11/3, and so that would be my b. So there is my equation that goes through these 2 points. Here we're going to examine how linear equations can be used to model real-world situations. salesperson Eric is paid a daily salary plus commission, and we're told that when he makes $1,000, or when his sales are $1,000, he makes $100, and when his sales are $1,400, he makes $120. Well, what that does is it gives us ordered pairs that we can use to graph a situation that represents his sales. The ordered pairs that we're given are when his sales are $1,000, then he makes $100. So what we're comparing is his sales to what he earns. So those are the two values that we're comparing, and that's important, especially when we graph it. So when his sales are $1,400, he makes $120. So that gives us two ordered pairs that we're going to graph, and we'll draw a line, and then we'll also create an equation for that. So because I know the sales are numbers like in the thousands, and 1,400 is the maximum that I have, I'm going to create units on the bottom that go by 200. So this will be 2, this will be 400, 6, 8, 10, 12, 14, 16, 18, and then 2,000. So that should give me enough room to create sales, because I'm going to graph the sales on the bottom, because that's the independent variable. And then what he earns is based on his sales, so that becomes the dependent variable. And those are numbers like 100, 120. So I'm going to go like 20, 20, 40, 60, 80, 100, 120, 40, 160, 180, 200. And that is what he earns. Now let's graph my 2 points. I have 1,000, 100, which is about here, and I have 1,400, 120, which is about there. And so I can graph the situation. So here's a good estimate of what the line would look like that compares his sales to what he earns. The next thing I want to do is I want to create an equation for this. And I'm going to do that by starting with the point-slope form. And the one thing that we're missing is we're missing slope. So I'm going to find the slope by taking my y, 120, and subtracting my other y, and then subtracting my x's. This is using the slope formula. So we end up with 20 over 400, which is 2 over 40, which is 1 over 20. And for our purposes here, we can call that 0.05. So that's the slope. Now I'm going to use that, and I'm going to plug that into the point slope formula. Y minus, I'll use the first one, 100 equals 0.05x, parentheses x minus 1,000. Now we'll simplify this. Y minus 100, and I'll distribute the 0.05. So 0.05x minus 50. Last thing I want to do is isolate the y to get this in slope-intercept form. So I will add 100. So y equals 0.05x plus 50. And this is the formula that represents Eric's salary based on his commission. So if you take any one of his sales and plug it in for x, and you do the algebra, that will give you what he is going to earn. Our last example has us write an equation that passes through a point, but it also talks about being perpendicular to this equation. Well, we've talked about perpendicular lines in the past. We know perpendicular lines have slopes that are opposite reciprocals. So if I look at the equation that I'm given, and I know where to look for the slope right there, I can find that my slope in this equation is -4. But I want a line that's perpendicular to that, which means my slope, or my m that I'm looking for, is the opposite, so it's going to be positive, and the reciprocal, so 1/4. So that's the slope that I'm going to use for my equation, 1/4. I know it also goes through this point, so I'm going to use point slope form. And I'm going to plug in my x and y from up here. So y minus 3 equals 1/4 times x minus -4. So minus a negative will end up being a plus for us. So y minus 3 equals, now I'm going to distribute the 1/4. 1/4 x, and remember that's a plus 4. And if you multiply 4 times 1/4, you get a 1. Then I'm going to isolate the y to put it in slope-intercept form. So we'll get a final equation of y equals 1/4 x plus 4. And that's the line that goes through point -4, 3, but is perpendicular to this equation.